Have joined. We'll, we'll slowly start. Wait for 1 or 2 minutes and slowly move. Yesterday we were talking about the washing machine as an example for mechatronic system, right? We see in house. By the way, why I am showing different examples are starting from your home: washing machine, fridge, correct? Then microwave oven, correct? And the coffee making machine, air conditioner. These are we call home appliances, right? All these things are mechatronic system. In the air conditioner also you have compressor, there's a fan, all this thing should be operated, and you have electronic control remote. There's a small microprocessor which can measure, then it has a temperature sensor which measures the room temperature, and according to set point it switches on the compressor or switch off the compressor, and the airspeed can be controlled, blowing, right? Cooled air blow, all this thing can be then. So that is an example for this one. Like that, wherever you see the whole idea of the example what we are discussing last 3 or 4 classes is, wherever you see you have a mechanical system controlled by electronic circuit and sensors using software. Yeah, small computer also is there. That is what called embedded controller. We are going to study about what is inside embedded controller, what are the different all these things. That is the course about, correct? Not specific to automobile. We are seeing general, including robot, all these things. So in the previous class we had talked about it. I talked about what is the washing machine components, correct, and the control system layout and functional block diagram. What are the actuator? What are sensors? How it works? I explained as a flow chart. In the exam, that's what is expected, correct? Whatever I explained yesterday, you need to write. When you ask for about, write about example for a mechatronic system, can be washing machine or automatic camera or engine control, something like that. That's what you are going to expect in exam. You are supposed to draw this functional block diagram. This diagram is not needed, as I told you, because this is to understand only, but this diagram you need to draw. This is called functional block diagram. That's what I call in my question paper. So you need to draw this, and also automatically you have to explain what the pump is doing, correct? Small water pump is used to suck the water from the overhead tank and fill the drum to required water level. That means each component you have to write definitely what it is. The water outlet for what is doing, correct? Just 1 or 2 lines. Then this motor I told you, this is the main motor which is going to drive my drum, correct? The tub, they call it a tub or drum. These are two names used in synonymally in washing machine terminology. The washing drum, or they call it a tub, inside which only water and cloth will be put, and it will be moved clockwise, anti-clockwise, and also the agitator, which is also attached to center. Both will churn the water. They basically going to be a churning of water. So the churn water, the velocity increase, the velocity, because the water will penetrate the gap between the fibers of your cloth. Wherever dirt is sticking, that will be removed. And I told you about also, I'm not going to repeat because I'm just waiting for the students to join. I think most of the students join. We'll go to the next example. I said one example, but I will give 2 examples today and close the example. Then we can jump start on. Because this is also part of the course. Please note that you can expect questions from what I talked till now. What is mechatronics? Define mechatronics, right? What are the mechatronic components? We have already talked about it. You have a mechanical system, functional block diagram. All the, because you can expect questions 2 marks, 3 marks. Generally, your midsem exam will be 30 marks. I already told you, correct? 10 marks. Each question will have subdivision. 2 marks, define what is a mechatronics. Draw a functional block diagram of automatic camera and explain with the proper flow chart and defining individual components. What are sensors used? What are the actuators used in the camera? Similarly, what are the components used in washing machine? Actuators. I showed you 4 important actuators, 4 important sensors. Draw the functional block diagram, mention this, and also briefly write what is function individual sensor and actuator. And after that, you write the working through a flow chart. Draw a flow chart and explain briefly. So 4 marks means you have to write at least 2 pages. You cannot write just whatever I showed, because many times students what I do is, sir, you showed only the functional block diagram. You draw the function whatever you remember. After that, something you write few lines. Sir, for 5 marks you gave 1 mark. You draw the function value, you get 1. Remaining 3.5 marks for writing the flow chart what I explained, and writing about what is the job of each component, what are sensors, You have to list. These are actuators used. These are sensors used. One electronic control. There's a washing drum or tub is there, which is driven by motor. Correct. So function. Then you draw the flow chart and explain. Then you will get full marks. And 4.5 marks something. Nobody get 5 out of 5. Correct. Unless you write whatever told all the point. So please remember, take note. That's why I'm again repeated saying, don't draw this alone. So this is what you showed in slide. I explained for 1 hour yesterday, more than 1 hour. Correct. All the point you have to write through flowchart. That is what expected in the exam. That's why I say you have to attend the class without fail and take notes. Fine. Today I'm going to talk 2 more examples. I think one is satellite. You know, the satellite are used for communication, for TV broadcasting, TV signal, your cell phone signal, or weather forecasting, or military purpose. Satellite are launched using in a rocket. Basically, you see that there's a rocket is a cylindrical. This one, correct, measuring maybe 30 meter, 40 meter height also, and maybe diameter, maybe 2 or 3 meter is the diameter of this one. It's a cylindrical shape, this one device, and there's a engine, rocket engine and end. And this is filled with fuel, right? This is filled with fuel and oxidizer. Rocket is filled with fuel and oxidizer. On top, you have a space where your satellite will be kept. Correct? This satellite from the you have your launch pad on the earth, correct? And once a rocket is fired, rocket engine is fired, correct? Rocket engine is fired. At a given time, it carries because there's a release mechanism which is holding, it will be released. Then the hot gas will come out, correct? Burn hot gas is coming out, and thrust is produced. Thrust is produced. Due to thrust, the rocket start ascending. Okay. So now when we talk about satellite, because the satellites can be launched at different altitude, because satellite is going to revolve around, correct? Revolve around the earth. So you have earth. If you think this is your earth, and satellite is somewhere here, that will be using rocket. You move here, and the rocket launches the satellite. After that, the rocket falls to the ocean. Over. That job is over. Satellite inside is launched. Once launched, the job of satellite is rotate in a circular orbit. Correct? So the height of the orbit can be around 400 kilometers or 36,000. There are 3 levels. This is called low Earth orbit. If satellite is launched to 400 kilometers, the satellite has to revolve around the Earth at the same height, maintaining same height. Wherever it goes, it also maintain the same height and orientation. That is called as altitude. Maintaining the height and orientation of the satellite as commanded when the initial launch is called as altitude control, not altitude control. Altitude is only height. It has to maintain the orientation with respect to sun, because the satellite is going to generate energy from solar panels. You can see that this is one solar panel, and this one. Apart from the internally, it can have a battery. Correct? The battery will be initially charged before launching. That is sufficient to drive the electronic component. Correct? What you call as a transmitter, receiver, all those things, they have to work for 5 to 10 years. Satellite life will be 5 to 10 years, sometimes even 15 years also, depending upon. Okay, that depends on fuel available in this inside the satellite. We are going to discuss later. Okay, so apart from that, there's a battery. Battery you can charge one time when before launching, but after 1 or 2 days, the power will be used by electronic circuit inside the satellite. After that, because all the electronic circuit need power. That power is generally generated with 2 ways. One is they may use the nuclear reactor. Small nuclear reactor, correct? Weighing maybe less than 100 kg, something like that. Correct? They use isotopes, radio isotopes, and generate electrical power using thermopiles. Thermopiles plus the nuclear reactor. Nuclear reactor generate heat, maybe 300, 400 degree. That heat will be used to heat the thermopile. Thermopile will produce electrical power. Most of the American satellites used for military purpose are interplanetary because they launch satellites going to Mars, Neptune, Pluto, all those things, long distance, where the sunlight is not available. Correct? Because if you see that Mars is 4 billion kilometers away, the amount of sunlight available at the Mars surface is very, very low compared to Earth. So the solar panel alone is not sufficient. Correct? If the satellite launches far away. So in that case, they use thermonuclear reactor plus thermopile. Thermonuclear reactor generate heat around 300, 400 degrees. That heat will be used for going to heat up the thermopile. Thermopile will generate electrical power. That will be used for driving, and the excess power will be stored in your battery. Anyhow, there will be a battery. Battery will be used for storing excess power so that it can be useful. That's how it works. Now, based on that is one thing. Next thing what I want to talk is when you launch the rocket will take your this one satellite from the Earth surface, from the launch pad to 400 kilometers within some 15 to 16 minutes. Right? That is called low Earth orbit. Low Earth orbit. Okay. So low Earth orbit is this one. Next one is medium height. Right? It may be around 4,000 or 5,000 kilometers. Exact number I will tell you maybe in the next slide I have. Last one is called geosynchronous orbit. Geosynchronous orbit. These are the 3 different orbits most of the satellites are launched. Whether launched by India, America, Russia, whatever the satellite is launched by any country, they will go and occupy any one of the orbit. Low Earth orbit, medium, or geosynchronous. Geosynchronous orbit, 36,000 kilometer height. Correct? So there are some advantages. We are not here to discuss all those things. So rocket will launch. After that, rocket will fall back to ocean or some desert area over. After that, so once that is launched, after that the satellite need to maintain its height. This is my Earth, and satellite is launched, say for example, low Earth orbit, 400 kilometer height, for example, and it has to rotate or revolve around this one, maintaining constant altitude. And also, as I told you, there's a sun. So this satellite, this is my satellite, it has solar panel. That's what is shown here. Please see that solar panel. So the solar panel should always, I have a sun here. This is my sun. Okay. The sunlight should always fall at the solar surface. This is top surface. Correct. So the solar panel also will be oriented, will be rotated such that it is always facing the sunlight. Both the solar panel, though it is the sunlight. So that means not only the height has to be maintained, correct? The altitude with respect to this one, and also because if you see the satellite, generally we talk about coordinate system. In mathematics, geometry, all this thing called as Cartesian coordinate system. This is called x-axis, this is called y-axis, this is called z-axis. So once it is launched with respect to Earth, this is my solar panel, this is my satellite, and it has to maintain this orientation with respect to Earth surface and also sun. So that is called a altitude control. In the x direction, what angle, y direction, what angle, z direction, what angle, also maintaining this height. Correct? It also follows circular path. That is called altitude control. To do that, inside, how will you design once launched? Correct? So once it is launched, the satellite has some velocity. Correct? Final velocity will be in the order of thousands of kilometers. Satellite will be launched, and since there is vacuum above where the satellite is moving, nothing to stop. Correct? But there may be little bit of gas molecules, because of slowly the satellite may lose its speed. So if satellite loses its speed, correct, to maintain the circular orbit, satellite has to maintain particular velocity, maintain a velocity. Initial, while launching the rocket, launching, before leaving, correct, it will maintain the particular velocity is given to the satellite. So the satellite will start orbiting, correct? So it will start orbiting. But after that, the rocket is fallen, then there are small thrusters. There will be small rockets here in the satellite itself, which will be oriented with respect to x-axis and y-axis and z-axis. That rockets are called thrusters. They are called as thrusters. Please note that thrusters are nothing but a small rockets, rocket motors. That means inside satellite, while launching, satellite has some volume and also has a fuel tank, rocket fuel. Rocket fuel will be stored inside the satellite also. That fuel will be used to fire the rocket. So by firing the rockets, and I can maintain the orientation, maintain the altitude. That means orientation with respect to x-axis, orientation with respect to y-axis, orientation with the z-axis. That is maintained so that the my solar panel always leads sunlight, and also my height with respect to earth surface maintained. To do that, the rockets are used. So this is called functional block. This is in exam. You need not draw this. I'm not going to ask you to draw this diagram. I took a picture, correct, to understand you. You can see that in the x-axis is called yaw, and y-axis called pitch, and z-axis called roll. In aircraft, in three-dimensional space, whenever you talk about airplane or a rocket or any object moving in this free phase, not touching this on three-dimensional space, we talk it as x-axis is called yaw control, y-axis is called as pitch control, and z-axis is called a roll control. So maintaining the orientation with respect to is called roll control, z-axis with respect to x-axis. I am talking with respect to rotational movement, that is called yaw control. That will be done, and height also will maintained by firing the thrusters. So this functional diagram shows what is called as the closed loop control system of satellite altitude, closed loop control of satellite altitude control. Again, I am repeating, altitude maintain only height alone. Now, altitude control also, because this satellite is, you can, with respect to the z-axis, it has to maintain some degree. With respect to x-axis, it has to maintain degree. So that the solar panel always points towards the sun. Accordingly, the thruster will be controlled. So to do that, there are two types of controls in this one. In the very small satellite, you will not have thrusters. Right? Rocket, instead of that, what you call reaction control wheel will be there. Reaction control wheel will mean that with respect to x, y axis, there will be three motors. There's a motor, and on the side there's a mass, solid mass, cylindrical mass. This is my motor. This is oriented with respect to x-axis. Similarly, with respect to y-axis, there will be a motor. Correct? There's a motor, and there will be a mass attached to it. So similarly, with respect to z-axis also, there's one motor. There will be a mass attached to it. Right? This is the mass. This is the mass. And there's a sap. These motors will be rotating these masses at particular RPM, fixed RPM, known RPM. Okay, all the masses will be rotated. Okay, you know that when some mass is rotating, and with respect to one axis, if you try to change move it, the mass inertial effect, we know about, remember the gyroscope, I think all of you know. Inertial effect prevents the mass to move because it is rotating with respect to z-axis. This is z-axis, sorry, this is y-axis. If I try to move the mass with respect to this, then the mass will oppose the movement. That is called the inertial effect, gyroscopic effect. That principle is used to maintain the particular direction. Because I told you, with respect to x-axis, with respect to y-axis, z-axis, the satellite is launched by the rocket and it maintained. Now, but you need to change the direction because you have to rotate around the earth, also maintain this one. To do that, the motor speed will be varied so that the inertial force generated will be varied. So by varying there are two ways of controlling the altitude control. If you can have this what you call thruster, inertial system, which is also called reaction wheels. Other name is called reaction wheel. Okay, you need three motors and which is aligned with the x, y, z axis of the satellite. But motor, all this thing already this one. And the motor will be rotating particular constant RPM. Maintain this one. But if you want to change this one, you will change the X motor speed, Y motor speed, Z motor speed. So the net this one, inertial forces acting will be make the satellite to maintain the same orientation under the rotate around this. Okay, that is one thing. Then if you want to give the velocity, what you will do is you will fire the thrusters. Right? If an object is in the space, for example, I take a cube, if it is in this one space, it has this one axis. It has 6 degrees of freedom. Please note that any object floating in this one has 6 degrees. So what is 6 degrees one? Movement with respect to x-axis. That is a linear movement. Correct? If the object moves in this direction, I say 1 degree freedom. From this is my origin, x comma y comma 0. If this object moves in this direction, I say the 1 degree freedom. Similarly, in the y-axis, if you start moving, that is another degree, 1 degree freedom. Similarly, in z-axis it moves, then I have 1 more degree. So that is called linear movement, Cartesian coordinates. With respect to origin, if objects move any of the direction x, y, z, I say that the object is floating, so it can move any day without restriction. So it has 3 degree linear movement. Apart from, with respect to x-axis it can rotate, with respect to y-axis it can rotate, with respect to z-axis also it can rotate. So you have 3 linear motion and 3 rotational motions. Yeah, object floating. So satellite is floating on the free space above the Earth's surface. So we need to maintain the velocity with respect to x-axis, with respect to y-axis, with respect to z-axis. So the satellite follow the circular path. That means that's why there are 3 thrusters. As I told you, there are 3. Totally this one. No issue. I can draw it. There's one thruster. Other thruster is like this. This is the Z thruster motor, not the rocket. This is X thruster or a small rocket motor. Same thing, correct? This is Y thruster. By firing these rockets, I can make my satellite to move in the X direction. I can move in Z direction. I can make it move in the X direction. So by controlling the rocket, correct? That is nothing but force, forward force, linear force. Linear force generated by rocket depends on how much fuel is burned. So inside rocket, they will be storing 1 ton of fuel to 2 ton of fuel. Correct? Please know the rocket. Satellite weight may be something around 3,000 ton to 8,000 tons also, because India launches satellite using PSL, GLC. They are around 3,000 to 4,000 kgs, not tons. Correct? 3,000 or 4 ton. Correct? American military satellite sometimes they send even 8-ton satellite. That correct? But our launch capability, rocket, PSLV, GSLV can launch only up to 4,000 kgs or 4 ton. Correct? But bigger rockets, maybe you can launch more weight also. So most of the satellite made by India, INSAT 1B, all this weather satellite also around 4,000 kg, around 3,000 to 4,000 kg. Inside that, if I say 3,000, out of that, maybe around 2,000 kg will be the fuel, rocket fuel. Okay. Now, as long as rocket fuel is there, I can make my rocket, the satellite to follow the path by firing the thruster rocket, this small rocket, correct? So that the circular path is maintained, so that height is maintained. And also using the reaction wheels, I can maintain the rotation with respect to x-axis, rotation with respect to z-axis, rotation with respect to y-axis, so that solar panel always point toward the sunlight. It receives the solar energy to charge the battery. So if the fuel, the rocket fuel is over, I tell to 2,000 kg, because very small fuel is sufficient to maintain the velocity, increase velocity, decrease, because there is no friction in this one. So this fuel may be there for 10 years, 12 years, correct? If you use carefully, the fuel will be there for 10 years, for example. Then I say my satellite life, please note that your satellite life depends on the fuel available, correct? Which is used for the thrusters to control the height, orientation and height, correct? So That is what the picture shows here. Okay, so in the satellite altitude control, you wanted to maintain desired altitude. That means I say 400 kilometer height with respect to this one, and also the theta and say psi and for example phi. This is the orientation with respect to x-axis. This is orientation with respect to y-axis. This is orientation with respect to z-axis. These three angle are maintained by the reaction wheel. I told you there are three motor with mass using the inertial force like gyroscope, and that is angle, that is orientation. This is orientation control. Orientation control is by varying the speed of the motor in the x-axis, y-axis. So net inertial force acting makes the satellite to maintain this particular orientation with respect to this. May be, for example, 75 degree. This may be say 180 degree. This may be 90 degree. For example, it has to maintain. This will be made to maintain by controlling reaction wheels. Similarly, using the rocket thruster, the velocity with respect to x-axis, velocity with respect to y-axis, velocity with respect to z-axis will be controlled by firing the rocket linear velocity. So the height is maintained. So together it called altitude control. This is how it works. So what are there? You need sensors for measuring the altitude. What is that? Theta, correct? Psi and phi. These three angles should be measured. Three angles should be measured. Inside the satellite, you have angle, that sensor. And also, once this is measured, then altitude control is by measuring the linear velocity. Correct? X, Y, Z linear velocity will be measured using an appropriate sensor inside that. And those sensors, by measuring this, I will fire, the controller will fire the rockets or the reaction wheel, change the speed of the reaction wheels, x-axis, y-axis, z-axis, or the x, y, z rocket motors. So the altitude is controlled. That's how it works. Okay. Basically, the altitude control, how it works, I told you, your understanding. And the main thing is, if you, in the exam, if you asked to write about satellite altitude for a mechatronics, you are expected to draw this. That is sufficient. And afterwards, what satellite altitude control I'm talking? Satellite operate in vacuum, generally 100 kilometers above. We say the space as per terminology, correct? As per say aerospace terminology, space means above 100 kilometer height. Above 100 kilometer, the atmospheric air, the density becomes so less. So you can, it is considered as a vacuum. Generally, we say space means there's no air. Correct? Air, water molecules, or the dust particle which is there in this one. This is there up to 100 kilometer height only. Already it has been proven by measurement. They have proven that up to 100 kilometer at the earth surface you have 1 bar pressure, but as you go up, the pressure reduces. That means mass of the amount of the air given volume is go on reducing. About 100 kilometer, almost there is zero air molecules or dust particles. All those things. They say it is space. Beginning of the space in the earth, above the earth, 100 kilometer, this one. And generally, I told you, satellites are launched much above their height to reduce the friction, all those things. So there are, in fact, there are 5, this one, orbits with respect to Earth surface. One is called low Earth orbit. Then next one is medium Earth orbit. Then the third one is called polar Earth orbit or sun synchronous. Then fourth one is called geosynchronous orbit. The last one is called Lagrangian points. With respect to Earth, and the Moon. Between this one, we know that recently Americans launched one telescope, space telescope, right? James Webb telescope. James Webb telescope, that is named, launched by NASA, right? The telescope is at the Lagrangian point between Earth and the Sun, so that it can remain in a stationary location and observe the universe. So, because I told most of the satellites are on the geosynchronous orbit, which is for weather forecasting, communication, cell phone, all the most of the, maybe around 10,000 satellites maybe will be revolving around Earth, launched by America, Russia, India, China, many countries for last 50 years. So many are not working and the majority are working. That is what used for this. They are in the low Earth orbit, or they will be in the geosynchronous orbit, majority. Correct? Other things are in between. Okay, that is the one thing. So what is the altitude control? It is called a two-body problem. Motion of satellite can be visualized quickly with a basic knowledge of 6 classical orbital elements. Correct? Classical orbital element we call, that is basic theory behind that. We need not worry. We are not going to launch satellite, all these things. Just wanted to tell you the terminologies. Maintain the relative position of the satellite with respect to Earth is called an altitude control, including orientation. That's not only position and height, including orientation with respect to XYZ axis. Correct? With respect to X axis, Earth surface taken as reference point. With respect to that, the satellite has to maintain particular XYZ angle with respect to reference frame. That is, and also maintain, that is called altitude control. The satellite altitude or orientation orbit control is controlled by system consisting of sensors and actuators and the software, because there's a small computer inside your controller. Inside your control, altitude control, there's a small computer we call ECU, electronic control unit. Sometimes there may be a small computer itself. Actually, this one it may use some like your laptop, desktop, like computer itself. Okay, or it can use this one. So it has that. Then the altitude or orbit control provides 3-axis stabilized Earth pointing altitude. As I told you, now my Earth is here. This is the Earth center, and my satellite is my Earth. Right? Earth also has a reference point, X, Y, Z axis. I say this is X, this is Y, Y, E. Earth reference, this is Z, E. And this is XE. With respect to this, it has to maintain some orientation. Okay, this is called a reference frame. In fact, they use what you call inertial reference frame. Inertial reference frame is with respect to stars. But for understanding better, I said with respect to it has to maintain. Okay, so then it has to maintain this height also, altitude, and orientation, which plus this is called an altitude control. So we have sensor already talked to you, correct? So this is called a reference frame. With respect to that, the satellite has to maintain particular angle. With respect to this X angle, this has to maintain. Okay, and it has to rotate. Already I explained how it works. So now altitude control Pro 3 has stabilized. It has to maintain same 400 kilometer. It cannot deviate. If it deviates, it will go and hit some other satellite launched by some other country. Each satellite is given specific orbit, 400 kilometer and particular orientation, and it has to maintain same thing plus or minus maybe few 100 meters or something. If it go beyond it may go into the other satellite, both satellite will be damaged. So that is why the altitude control is very important. It has to control very accurately orientation, all those things. So the position, orbital position should be maintained, which is called altitude. Okay. The gravity, main thing is why we have this. I told you in this one you have a small thrusters, 3 thrusters, and also 3 motors. This one to make the thrusters. Without thruster, the satellite will fall back to Earth because of the gravitational force. Gravity is pulling the satellite. Correct. So if satellite has to maintain, it has to have some forward velocity. It should have always forward velocity. The forward velocity is achieved using the thrusters. By firing the thruster, satellite gets required the forward velocity so that it won't fall down due to gravity. Correct. So that's why the fuel, rocket fuel inside the satellite determines what is the life of your satellite. If the fuel is burned and within 5 years, the circuit may be, electronic circuit may be working, but satellite is dead because it cannot have the forward velocity, and slowly it will fall on the Earth and rotate and fall on the Earth. Slowly it will lose the height and come and hit the Earth, it will be destroyed. So basically that's what happened after the end of the life of the satellite. They controlled the Indian satellite. ISRO will control the satellite. If the fuel is over, they will make it to fall on the ocean so that it will not fall on any humans, on city. Correct? There's a controlled descending and destroy it. Otherwise also, if fuel is there, it can fall anytime, anywhere. It should be dangerous. So now till the now forward velocity, maintain a forward velocity, then only height can be maintained. Correct? And so by firing the X thruster, Y thruster, all those things, the resultant this one, correct? There are two result. Say, the force at the X direction, force at the Y direction. Then if you both the rockets are fired, then a resultant vector, correct? This is called resultant vector. Already you know about trigonometry. The resultant vector, this is the direction rocket will go. If I fire X rocket and Y rocket simultaneously, the rocket will not move in the X or will not Y, it will move in the resultant direction. Similarly, if I fire Z also, in 3-dimensional phase, it will maintain a particular orbit. By firing the rocket, only the particular altitude is maintained. Correct? For that, that is what the altitude control. Correct? That's how it is done. So now already told you that gravitational force makes the Earth satellite to a specific and predictable path and orbit to move around. But if you don't fire the rocket, the satellite will fall. Next day it will fall. Within few hours it will fall. So you will be continuously firing. Who is going to control? The altitude controller. This will be firing the thrusters, rocket thrusters continuously are required, and by measuring what is the current altitude using the sensors. Okay, that's how it works. So basically the gravity, correct, is going to be the gravitational force acting on your satellite is based on this formula Ag and msat, where A is the gravitational force or acceleration, gravitational acceleration, correct, that can be calculated using this. I'm not going to ask you to write all the formula, just making you to understand, because this question will be how it works and how the controllers work, what are sensors needed. So the velocity, this is what I do. Prime thing is the net resultant velocity of satellite is given by this formula, where R is called the from Earth center. My satellite, bigger Earth itself has a radius. Correct? This is Earth center. There is a Earth radius from center. From that it goes up. This height is, I say, 400 kilometers. From here, you have to take this also. Correct? This R consists of from center of Earth to satellite height. So this radius, Earth radius also is taken. Then once it is known, then using this formula you can know what should be the velocity of the satellite, so that it will follow the circular path. Correct? This velocity is maintained by firing the rocket thrusters in the X direction, one rocket thruster, Y direction, Z direction. So the velocity is maintained. If you maintain velocity, automatically, see, gravity is pulling down. Correct? Where the gravitational force is pulling down, but these thrusters are forward velocity is trying to move like this. So the resultant will be, correct, it will be moving like this. This is pulling like this. So resultant is circular path. Correct? If the forward velocity, if not there, this force will become zero. Satellite will fall and become gravitational force. So that's why this is how the altitude is controlled. Any questions in this?
What is mu then?
In this mu is specific mechanical energy required for maintaining orbit.
Oh, sir, okay, that I thought was epsilon. I meant the numerator of the numerator in the equation where
here this one mu. I think mu is the if you remember, this is a frictional constant or something. I will come back to you. Sorry, I don't remember right now. Okay, I'll tell you next class. You remind me to. Okay. So this is how it works. So this gives the overall control system, altitude control. There are sensors, and the sensor signal are processed by electronic, because most of sensors provide signals in the order of millivolts, microvolts that should be amplified. This is nothing but amplifier circuit, amplifier signal. Correct? That signal goes to the controller. So this is a whole control system. Correct? And then there are power system, power conditioning, and there are propulsion module. This is nothing but the thrusters, rocket thruster. Correct? Control. And there's a telemetry command. The altitude, if you want to change, you can control. Suppose satellite is not working from the Earth, ISRO will send commands to this controller to, if something goes wrong, using telemetry means wireless communication from Earth, the ISRO ground station they call it. They can control that. And these are the sensors, correct, to measure. Okay, these are actuators. These are nothing but the reaction wheels. Reaction wheels, please note what for reaction wheel, to control the orientation of the satellite. Orientation of satellite with respect to x-axis plus x-y-z, all three axes. Sorry, x-y-z axis. Correct? The reaction wheel by control, changing the motor speed, the mass of the, correct? I already told you, there's a motor which is connected to a mass. The mass may be 3 kg, 5 kg, 10 kg mass, which will be rotating. If the motor is rotating, this mass at say 1000 RPM, correct? The inertial force may be x value. Inertial force, correct, will be x value. Now, if I may increase it to 2000, it will become maybe 2x, correct? So, by varying the motor speed, I can increase or decrease inertial force acting in the particular axis. So, this is for x motor, y motor. By doing that, I can control the orientation of the satellite. That is called reaction wheels. This wheel is called reaction wheel because it's going to react if we change the speed of the motor. Because please note, it is firmly attached. If motor speeds are automatically, the mass of the rotation speed changes. If we try to change this one, and if satellite try to move from the current axis with respect to the z axis, that will be opposed by the inertial force. Correct? By varying three motor speed varying, I can change the orientation of satellite with respect to x, y, z axis. That is done using reaction wheels. The thruster motors, again you remember, thruster motors, please note that is not electric motor, it is the rocket motors. They are going to control the linear velocity, with respect to of the way this one with respect to x, y, z. As I told you, if you fire two rockets simultaneously, then the resultant force vector will be in the 45 degree. If the same amount of force is created x and y direction by firing two rockets, say for example 10 Newton, the result, as I told you, this is x 10 Newton force, y also 10 Newton force, correct? The satellite, this is my satellite, it will not move in x, or it will move in the resultant 45 degree angle, correct? 45 degree angle, this is the motion of the satellite. So like that, by varying the, if I want to move 30 degree, this will be less, this will be 8, this will be 12. So the rocket will move in this direction. So like that, that means the particular altitude is maintained. So this is how it works. Okay. So to find in a modern this one, they use additional receivers like GPS receivers. Sun or stars will be tracked, and they use magnetometer and also to measure the height. Correct. So as I told you, this is my Earth. This is my satellite. The height has to be maintained. Say 400 kilometers. This is my satellite. This is my Earth. So the height will be measured using any of these mechanisms. GPS receiver or a sun or star tracker. It has a small telescope and there's a sensor. It measures the position of the sun and this one accordingly. This one. And then gyroscope can use or magnetometer. Earth is having magnetic field. As you go away from the Earth, the magnetic field strength measured by magnetometer reduces. Using that, the altitude, correct? I am talking about altitude, height. That is measured using any of the sensors. Magnetometer is used in the modern. This one, that's what it. So, with this we will end the one example. Another example of mechatronic system. Satellite is a mechatronic system, correct? It has a mass, it has a structure, and that height has to be maintained in particular orbit, orient has to maintain. By controlling, you have a control system, there are sensor, there are actuators. What are the actuators? Reaction wheel and rocket thrusters are used as actuators to control orientation, x, y, z direction, and linear velocity. Right? That you have angle sensors and also magnetometer. For example, you may use all to measure and the linear velocity, correct, and height. So then by firing, you are making, that's how it works. The next example, what is time now?
Sir, 5:45.
5:46, sir. 45, sir.
Okay, let me stop here. So we'll in the next class we will continue with, when is our exam? Midterm exam we have fixed.
One is on
Sir,
October 15 and one more is on October 20. 1 week
October
apart.
15. Okay, fine.
15 and
Okay,
20.
okay, fine. I think 15 is my exam, correct? Mechatronics, 15th, October 15th, correct?
13, sir. The slot that shown was 13th. 1 3.
1 3.
Yes.
Okay, today is 4th. So we have another 10 classes, no problem. Okay, fine.
right.
So have a nice weekend. Thank you. See you on Monday.
Sir, that is
Just
for
one
October.
question, sir.
October
Excuse me?
13th. That is for October
Please
13th.
explain how the
No, can you talk only one person? If you talk too many, I'm not able to hear.
Okay.
Amit, you are talking something.
Yes, sir. Can I?
Yeah.
Thank you. How is the altitude calculated, sir? I was just not able to follow.
No, altitude can be calculated using magnetometer.
Okay.
The magnetometer is used to measure the altitude based on the satellite position with respect to Earth height. Correct? You have Earth. Earth is from North Pole to South Pole. Magnetic field is there. The Earth magnet goes up to thousands of kilometers, like this. Satellite, in that there's a magnetometer. The magnetic field strength is measured. Earth magnetic field is measured using magnetometer. From that, it calculates what is already they are measured. If from Earth surface go to 1 kilometer, on the Earth surface, say magnetic is so many Teslas. Correct? So magnetic field is measured in terms of Teslas. Correct? Field is strength is measured Tesla. Say 1 Tesla, 2 Tesla, something. On Earth surface, for example, Earth magnetic field. Magnetic field is created inside the Earth, in the core. Please note that core is made of iron. And the iron, this one, the very solid iron, but very high temperature, 5,000, 10,000 degree, but it is solid. If you are known little bit, I will tell you, just few minutes is there. If you see that, you have 3 structures in Earth. Correct? Innermost is called core. It is mostly made of iron. Correct? It is like a solid, high pressure, like a solid, a spherical shape. It has maybe around 100 maybe 100 kilometer with the diameter. The core diameter exact number 50 or 100 exactly, I don't know. After that, you have another layer, outer core. This is called inner core. The outer core, I will use different color. The outer core is a molten rock and iron. It is liquid iron plus other minerals, including gold. Please note that people say that inside there may be thousands of tons or millions of tons gold may be there in the inner core, but you cannot go there because temperature very high. Correct? Then the next one is called the mantle, top surface. Correct? From here to here, you have around 3,000 kilometers, approximately 3. Total diameter is around 6,000 something. Earth diameter around 6,000 kilometers. Correct? And above that, you have your satellite. Correct? So this liquid part is rotating with respect to core. So since there's a movement and is made of iron material, magnetic field is created. They have electrons also. Correct? Ion is electron, inside which iron core, the liquid core is rotating, moving. There's a relative motion between outer and the inner core and the in between. So since it's moving, it is creating magnetic field. Correct? Earth magnetic field goes up to thousands of kilometers. But on the Earth surface, I say that is 100 Tesla. I don't know exact number. That is magnetic strength. If I go to say 10 kilometer height, it may become 90 Tesla. Or so for example, 95 Tesla. If I go to 200 kilometers, it may become 90 Tesla. So that is measured using magnetometer. In the satellite, you have a magnetometer which measures what is Earth magnetic field at that height. From that already is calibrated. I told you they already are measured and ignored. If the magnetic is say 50 Tesla, I can know that my satellite is a 400 kilometer height. For example, I don't know exact number. I'm giving a big number for understanding. That's how it measures. Altitude is measured using this sensor. Correct? The velocity and angular, this one is measured using angle sensor. Correct? Using gyroscopes or IMUs, inertial measuring unit. IMUs are used for measuring angular movement. Where it is there, it will be part of this sensor. Here you may use IMU. This measure the theta, psi, per YZ axis. This is called orientation. Orientation is measured using IMU, and the altitude from the Earth's surface measured with magnetometer, and forward velocity is measured using accelerometer. Accelerometer used for measuring XYZ linear velocities. So you will have three sensors: accelerometer and IMU, and also magnetometer. These are sensors used as feedback sensor. Any doubt?
No, sir. Thank you.
Okay. So please note that I explained for 1 hour. You are expected to write the important points in the exam. If the question is asking you write about my satellite altitude control, explain a mechatronic system working. Example, this one with the proper functional block diagram, and explain it. What are sensor use, what are actuator use, how it is working. You are supposed, right? You may get 3 or 4 marks question, not more than that. There you have to draw this. Let me clear this, then you will understand what this. You have to draw this diagram, right? And if you want to like, then put a line sketch. You can show something like Barclay structure. That is not important. This I am not going to ask that, but generally you have to maintain a height, right? And then you have to, what is altitude control? I am explaining. This part you have to write. What is altitude? Maintaining the height and orientation of the satellite with respect to Earth's surface using sensors, actuators, and control software, which will be running inside the controller. This controller is a small computer. We call it as ECU, electronic control unit, right? Inside satellite, the electronic control unit is a computer. It has a CPU, it has a memory. There you write your control software, algorithms to control the actuators. This is going to control the actuator based on the data coming from the sensors. So this is class of closed loop control. Closed loop control of satellite altitude. Okay. So then the key points you have to mention under the right. So that's how. That's it. I'll stop here. The next class we'll talk about engine control. That is going to be really very important, because being automotive, of course we are going to, you will be some professors already talked about pollution control, all those things. I'll run autonomous vehicle also. When I talk, I will talk about engine control, diesel engine control. This one you can see that. This we'll see next class. Then we'll go deeper into mechatronics, what mechatronics, all these things. Then we'll talk about individual, what are differences, what are as per syllabus we'll go. Thank you. Please give your attendance before leaving. Okay. Have a
Thank you,
nice
sir.
weekend.
Thank you very much,
Yeah.
sir.
Take care. Okay.
Thank you, sir. Thank you so much, sir.
Thank you.
Thank you, sir. Thank you, sir.
Hello, Vijay, Prabhakaran, Vigneshwaran. Hello, who is there?